All right, geometry scholars, welcome back to the drive-through, and a special shout-out to Mr. Lothrop version of the drive-through. As always, sponsored by the deli. Hungry? Stop by the deli. Make yourself a delicious turkey Reuben with sauerkraut on light rye. All right, this is 4-2, the case of the missing diagram, as the book calls it. Okay? Once again, there's nothing new here. No new vocabulary, no new theorems, okay? But we are giving you guys time to get used to the fact that things in here are getting more and more difficult by the day, okay? So, let's get right to it. Here are our action plans. First, widmapoi. When in doubt, make a picture of it. You're going to have to do that every single time. There's no way around it, okay? The second thing you should do is read the problem again and list the givens. Okay? Then, list what you're trying to prove. Be sure you're ready for detours and double detours. And then the only thing you have left to do is to make sure you enjoy it, because it's a challenge, because it's geometry for enjoyment and challenge. Here we go. Let's try it. If two altitudes of a triangle altitudes, what's up altitude? If two altitudes of a triangle are congruent, then that triangle must be isosceles. Okay, well, what's widmapoi? It kind of looked equilateral, and I don't want it to be equilateral, so I redrew it. Okay, so I've got a triangle that appears to be isosceles, but I don't know that it's isosceles because I'm trying to prove that it's isosceles. But what we do have is we have a couple altitudes. So that's going to need to be an altitude, so that has to be a right angle. And that's going to need to be an altitude. Okay, so we've widmapoied. If two altitudes of a triangle are congruent, well, I'm not going to be able to say that these are congruent without giving them letters. So, let's see. How about D, O, G, and C, A, T. Okay, we got dog and cat in there somewhere. Now let's write our givens. I'm going to read it again. If two altitudes of a triangle are congruent. So we know that OT and GC are altitudes. We know that. I hope you read it again, because you do have to read these a number of times to get all your givens. We know that OT and GC are altitudes. If two altitudes of a triangle are congruent, well, we also have to say that OT is congruent to GC. Okay? What are we trying to prove? We're trying to prove that it's isosceles. So we're trying to prove that DGT is isosceles. All right, we're ready to go. All right, so we're going to start with GC and OT are altitudes. Okay, and that's going to allow us to know that angle GOT and angle TCG are right angles. And that's the definition of altitude. Okay, now I'm going to look at this. I know I'm going to have to prove these triangles congruent, and I think I'm going to do it by HL. Okay, so I don't need to say that those angles are congruent in order to use HL. So I will just say that OT is congruent to CG, And that's another one of my givens. You could have had all those in one step if you want. I think this might just explain the process a little bit better. And I can say that, well, look, here's what I've got here. Okay, so if I could get that the hypotenuses were congruent, which would be these, then I could use HL. Okay, well, that's easy. I just got to use reflexive. Okay, so now I can say that GT is congruent to GT. And that's reflexive. So now you might see that I can prove that triangle OGT is congruent to triangle CTG by HL. Postulate. Okay? Well, look, now I'm going to be able to say that angle OGT is congruent to angle CTG and that's CPCTC. So I just proved that this angle was congruent to that angle. Hopefully you're starting to get used to this. Some of you would skip right to the answer, and according to the book, that would be okay. I like to just write this out. That means that OG, that should be an O, OG is congruent to CT. No, it was DG the whole time. I'm sorry. DG is congruent to DT by if two angles from a triangle are congruent, then the sides that are opposite from those angles must be congruent. And finally, my last step is I could say triangle DGT is isosceles. Because that meets the definition of isosceles. Okay? Let's do another one. Alright, if the line joining a pair of opposite vertices of a four-sided figure bisects both angles, if a line joining the opposite vertices of a four-sided figure bisects both angles. Okay, I'm getting it. All right. So let's call this hugs, because who doesn't like hugs? All right. What are we given? I'm going to write the given down in the proof here, okay? Just to save myself a little bit of time. So, I'll say that SU bisects angle HUG, angle hug, and angle HSG. Okay, is there other givens? If the line joining a pair of opposite vertices of a four-sided figure bisects both angles, that's really all I'm given. I'm trying to prove that angle H is congruent to angle G. Then the remaining two angles are congruent. Remaining. Jeez. Alright, I'm trying to prove H is congruent to G. Alright, this isn't going to be all that bad at all. Okay? The wording was the hardest part. The proof itself is going to be easy. Angle HUS is congruent to angle GUS. And also, at the same time, angle HSU is congruent to angle GSU. And my reason for that is definition of bisect. Okay? So let's mark my picture before I get confused. I now know that and that. Oh, I got this. I see angle, side angle right there. So I can say that US is congruent to US by reflexive. Okay. Now I've got triangle HUS is congruent to triangle GUS by ASA. Postulant. Okay. So now we know that angle H is congruent to angle G by CPCTC.